Hello, hello, hello. Hello, Haripriya. You're able to hear me now? Haripriya, did you solve this question?
Sir, 1 minute, sir.
Mhm.
Sir, option D, 81/64.
Oh. Correct. It's 81/64 only. How it is done? Uh, wait, let me do it. Let me solve it, then we'll move on to the next part. Yeah, sigma is same for both, na? The length area, length into breadth. Hmm. Okay. It's easy only. Just have to put the values. Put the temperature in Kelvin. T1 is 400 Kelvin. L2 is L1 by 2. V1 by 2 into 600 power 4. Hmm. Hmm. Okay. Now till where we have completed? We have done Stephen Boltzmann law with surrounding we have done. Okay. Now see, now what I'll teach you, na? Newton's law of cooling is also there. That also need to be taught. That also need to be studied. It's actually derived from this only, that this the heat loss due to radiation, no? From that only it is derived. It's a special case. This is the last topic of this, and then it is hanging. Okay. See, Newton's law of cooling, we know from this radiation, we know dq by dt is actually equal to EA sigma into T power 4 minus T naught power 4 is there. There's no problem in this. Now it is okay. See what is there? Na? dq by dt is EA sigma into T power 4 minus T naught power 4 is there. Now suppose we know whenever a mass, suppose there is a mass m which is losing heat. it is having a specific heat S. So I can just write dq is equal to ms delta T, where the temperature delta T is the temperature change over the period of time. Now, what I can write this one dq by this equation again I can write as ms d temperature by dt is equal to EA sigma T power 4 minus T naught power 4. Now I can write this one as d temperature by dt is equal to EA sigma by ms into T power 4 minus T naught power 4. Now, since the mass, the change in the temperature of the mass is given to be delta T. So let's say initially the temperature of T of the mass was T, and there is a change of temperature delta T. So what will be the final temperature? T plus delta T it should be. So I can write this equation as d temperature by dt is equal to EA sigma by ms into T plus delta T whole power 4 minus T naught power, or I should write T naught plus delta T. So it will become d temperature by dt is equal to EA sigma by ms. If I take T naught power 4 common, it will become 1 plus delta T by T naught whole power 4 minus 1. Right?
Yes, sir.
This I will approximate actually. I know for binomial approximation I can do 1 plus x whole power n is approximately equal to 1 plus nx. So it will become 1 plus 4 delta T by T naught minus 1. This will cancel out. So it will become EA sigma T naught power cube 4 sigma by ms delta T. So now see from this equation what we are getting now. The d temperature by dt is actually proportional to the change in temperature. The change in temperature of the body. Understood? Means
Yes.
situation is there is a mass m, surrounding was T naught at a temperature T naught. Its temperature, the temperature of the mass is higher than the temperature of the surrounding by a factor of delta T. Means its temperature is T naught plus delta T. So the heat released due to this, for this we are creating this equation. Okay, this one. Now you have to understand this is a relation that we have got Newton's law of cooling, where d temperature by dt is the rate of change of temperature, where delta T is the temperature difference between the mass and the surrounding. You can also write this equation d temperature by dt is proportional to T minus T naught. Now there is an approximate formula for this also. Usually, see, whenever we solve question, first we use this equation. It's not loading. What happened? First we try to use this equation. This is our first line of solution. First we try to use this equation. Then if solving question is becoming more difficult, using this power 4 calculation is becoming more difficult, then in that case you can use this approximation method. This or this. 2 or 3, whichever you use, find it easy. Okay. First you have to solve using this first one. Now there is a if there is a information lag, means there is no information, less information is given. In that case you can use this approximated form, that is d temperature by dt. We know it is equal to k into theta minus theta naught. So here, if the temperature of the body is changing from theta 1 to theta 2 and the surrounding is at a temperature theta naught, then in that case you can write this equation as d temp, that is temperature changes theta 1 minus theta 2, which you can write as dt. Theta 1 minus theta 2 dt, temperature changes t, this will be equal to k into theta is the temperature of the body at any time t. You can take as average of these two temperature. Okay, if this actually helps in those times when you have to find out the temperature, when you have to find out the time, and it is only given that the mass is changing its temperature from theta 1 to theta 2 and surrounding temperature is theta naught. Nothing else is given. In that case you can use this equation. Okay, now this is the Newton's law of cooling. Let me give you some question related to this. Try to solve this question. Today it's not working well. Try to solve this question. This question is, I think, from the Newton's law of cooling only, but which form you have to use, you have to apply your common sense.
Sir, 7/10 minutes.
7/10? No, they're saying it's 0.5.
Sir, I got 0.7.
They're saying it is 0.5. How did you solve?
I took dq by dt is equal to k theta minus t.
Ah, so d temperature by dt is equal to k into t minus t naught. So cools from 94 to 86 in 2 minutes. यानी कि 94 minus 86 divided by 2 is equal to k. What's the surrounding temperature? 20 degrees Celsius. This is first equation. Second equation will be how much time it will take? 71 to 69. 71 minus 69 divided by time t is equal to k into.
So you could have taken 90 minus 20 mostly.
Why?
Sir, average of 94 and 86.
Acha, that you are saying. Then what you will do? Then you will find out value of
I
k.
substitute k in equation 2.
Like that also you can do. Correct. I think your answer is more correct. Right, you are. 94. So here k into 94 plus 86 divided by 2 minus 20 will do, right? This is 8 by 2. So 4 is equal to k into 180 means 90 minus 20. So k will be equal to 4 upon 70. That value you will put here. 2 by t is equal to 4 by 70 into 71 plus 69 by 2 you have taken, no? Minus 20. 70 by 2. 70 minus 20. 50. 0.7. 0.7 seconds is the more correct one. This approximation only you have to do here. Correct. Your answer is right. Acha. You understood now how to apply this one, Newton's law of cooling? Approximation in this case you have to use, and otherwise if in other case you can use this one, T minus T naught. If temperature is given to you, then you have to, temperature of the body is given to you, then you have to use this formula. First you have to use that formula, first one, or you can use the approximated one. If temperature is not given, then use this approximate one. So now one more law I'll teach you, and then I'll ask you to solve some more questions of JEE Main. Next is Wien's displacement law. This Wien's displacement law actually works only for black body. In this Wien's displacement law, what they say, lambda mt is equal to constant. where lambda n is what? It is the wavelength of the radiation. T is the temperature of radiation. For black body. For black body, whenever radiation is going on, if lambda m is the wavelength of radiation, T is the temperature of radiation. In that case, lambda m into T is constant. That's Wien's displacement law. Okay. Now let's solve some questions. Concept-wise, the topic is over. What's happening? Why it is not sinking? See, this is the question. Try solving this. It's not difficult, but it was asked in JEE Main 2025, latest one.
Sir, option B 16E.
No. Why? The answer they are saying is E. See, let me solve for you. Two spherical bodies of same material having the radius, they are spherical bodies. Their radius are different. R1 and R2, let's say. R1 is 0.2 meter and R2 is 0.8 meter. Temperature of the smaller body is 800 Kelvin and the bigger body is 400 Kelvin, say. Energy radiated from the smaller body is E. Energy radiated from the bigger body is. Surrounding is to be neglected. So we know energy Q is equal to EA sigma T power 4 into time. E will be same for both, sigma will be same for both, temperature and area will be different because for the area first one is 4 pi r1 square, for second one surface area is 4 pi r2 square. So the energy for the first one is E. E is equal to, I can write this like this, E is proportional to A into T power 4. E is proportional to 4 pi r square is there, no? 4 pi is again a constant. So I can write E is proportional to r square T power 4. R is the radius. So for first one it will be E1 is proportional to r1 square T1 power 4. For the second one it will be E2 is proportional to r2 square T2 power 4. E1 is E they have given. So E2 by E dividing the both is equal to R2 by R1 whole square into T2 by T1 whole power 4. Now let's put the values. 8 by 2, 4 square. Let me do it more detailed. Eight by 2, 0.8 by 0.2 by 2 whole square into T2 is 400 divided by 800. Whole power 4. 2 the 4 the 4 square by 2 power 4. 16 by 16, 1. That's why we are getting the same answer. E2 is equal to, correct only. Why you got 16E? Haripriya, what mistake you did? Okay, you understood now how I solved this one.
Yes, sir.
So I now try to solve this one. Was it difficult? It was in JEE Main 2025.
No, sir. It
Hmm.
wasn't that difficult.
It was easy only. What about you, Kanishka? You did? Understood?
Yes, sir.
Okay. Let me put one more question here. It's not smooth today. It's taking time. Try to solve this one. I think this question is for conduction, na? This question you have to solve
Yes.
using conduction one. Hmm.
What 360 Kelvin?
360 you are getting, na? 60. Kanishka, you are getting the answer. Haripriya got the answer. You are getting the answer or not?
Yes, sir, I'm solving.
You're solving.
Just calculating the final answer.
Area is not given. Did they give you area? Acha, acha, acha. RA or RB is given, na? Okay. RB, RA by RB is given, na? 4. LA by LB is half. So LB by LB, LA will be 2. This is PK. What question should I give you? Acha, this is a different one. Try solving this one. Then from next class, we'll start waves. Sound waves. Why it is hanging? It's not loading to properly. Try solving. Try solving it. If you are able to solve in 3 minutes, okay. Otherwise, take it as homework. Just try to understand it first, because it's related to the phase change. Take it as a homework. Okay, try to solve it at home. Next class, we'll start a new topic. It's waves. Okay, let's end it now. Bye bye.